researchers.
Sorry.
No, thank you for starting the recording. And so we want you all to be able to take full advantage of having access to the actual full OMOP instance that we maintain with Stanford data. And like I said before, BigQuery is cool and has a lot of nice features that can really help make data exploration a lot smoother. So first, we'll talk a little bit about STARR-OMOP because we need to know what it is that we're working with if we're going to play around with the data sets here. So just a brief introduction. I know some of this will be familiar to some of you, but not to everyone. So I want to situate everybody. OMOP stands for the Observational Medical Outcomes Partnership, and it is now maintained by Odyssey, which is Observational Health Data Science and Informatics. That's kind of the organization that owns OMOP. And we often use the word OMOP to refer to a database that is set up according to the OMOP Common Data Model. So it's both the name of the partnership, and then it got co-opted and is now sort of what we call the data model and the data that exists in that. And so this is just a screenshot from some of the OMOP tables of like what this actually involves. This is taken from the Odyssey pages. So what is STARR-OMOP then? So STAR stands for Stanford Research Data Repository. Whenever I see that, I'm like, someone really wanted to make STAR happen because there's definitely a very selective choice of letters and words there. But it's basically Stanford's OMOP instance. So it's the data coming out of Stanford's healthcare system, both the adult and children's hospital. And then our team and various other folks over the years have worked to transform this into the OMOP common data format. So that's why we call it STARR-OMOP. It's specifically our data in the OMOP format. And the de-identified light data set, and we'll talk about what that means in a minute, is refreshed weekly. So you can get pretty up-to-date data for whatever your research needs are. And you can use just the latest data set on BigQuery to get access to that most recent data available. There's also some special features that are specific to Stanford OMOP or STARR-OMOP, which aren't necessarily part of the general OMOP common data model, but we do have flowsheet data available. We've stuck it into the observation table as JSON strings, and there's a specific concept ID to indicate that that's flowsheet data in the observation table. So if that's something you're interested in using, that is available. We also have information about zip codes or ZCTAs, approximately zip codes. And then we also have insurance mapping information. So depending on your particular research needs, we have these additional features available beyond the standard OMOP model. So within OMOP and even within a given data cut, we have several different options that may or may not be available. So just to situate you in terms of this sort of universe of names, the main STARR-OMOP CDM5, that's like the version of the common data model that we're on, and then the date is the fully identified OMOP. So most of you are not going to be accessing that. That's sort of part of our process of coming from the source data and getting it ready for researchers. We go through this stage of having a fully identified OMOP. And so that contains the actual dates and addresses and the original patient IDs and notes and everything. From there, we have a de-identification process, which involves jittering dates, removing address information, like granular address information, and using hiding in plain sight to replace names and other sensitive information in the notes. So that's like replacing names with alternate names rather than just removing them. From there, we have a DID Lite version, which is essentially the same as the DID version, but the notes are not included at all. The notes take up a lot of space and they're difficult to de-identify. And so the Lite version is just, it's faster to generate and faster to work with and doesn't take as much storage space. Then we have the DID 1% Lite, which is a 1% random sample of all of the patients that are in the full OMOP. And then it is complete data for each of those patients. So it's not a 1% random sample of each table independently. It's a 1% random sample of patients, complete information for those patients. So if you are testing your queries or developing your queries or otherwise doing something that doesn't require you to have all of the data, we recommend working with the 1% data set because that's going to be much more efficient, both in terms of your time and in terms of the cost of running these queries. And then for all of these, the date in the year, month, day format is the date that the data was extracted from Epic. So that'll allow you to figure out exactly what data cut you are working with. Any questions so far? No? Okay, great. So what is the CDM? CDM stands for Common Data Model, and it is a person-centric or patient-centric relational database. And the CDM has requirements both on the structure of the database, so what the tables are and what variables there are in the tables and how they link together, as well as the contents of each of those tables. And so there are quite a few tables that make up this overall database. There's clinical event tables, which are like condition and procedure and measurement. There's vocabulary tables, which help define all the terms that are used in the rest of the tables. And then there's these health system data tables, which contain information about providers and care sites and so on. And then some other tables that I don't think are as important for most researchers, so I've listed them here, but the font is getting smaller in accordance with my perception of their usefulness to most researchers. So there is some like payer information and so on, metadata tables, but mainly you'll be using the clinical event tables and then supplementing with the vocab and the health system tables to get a full context for those events. Yeah, and so the CDM specifies what goes into each table. So diagnoses go into the condition occurrence table, lab results go into the measurement table, and so on. And then we have to represent that information in a way that is in accordance with the CDM. And so we use concept IDs, which is the OMOP way of representing pretty much everything. And we will discuss that later. So there is really thorough documentation for all of these tables. Let me just bring this up really quick. So for each of these clinical data tables that I listed, there's 16 of them, then we can see all of the fields and what those fields should contain, and then a bunch of other information about those tables, as well as a high-level description of what should be in that table. So anytime you're starting to think about like, can I use OMOP? Does OMOP have the information I want? What tables should I check? I would recommend coming first to this documentation. Okay. What is a relational database? So I mentioned the CDM is a person-centric relational database. Relational database means that it is a collection of separate tables, but they can be linked together using specific variables that are designed to be able to associate one table with another. So the linking variables between these tables are called keys. Again, some of you might be very familiar with this, some of you might not have heard it before. The primary key is the unique identifier for that specific table. So each row in a given table has a unique identifier in this in the CDM. And then the foreign key is a way to link the row in that table to a different table. So in OMOP, the primary key is typically a single field that is called the table topic _ ID. So for the person table, the primary key is person _ ID, which makes sense, easy to remember. And then foreign keys look similar, but they actually refer to a different table. So on the person table, location _ ID is a foreign key because that's going to allow you to link to the location table and to a unique row in the location table. So a quick diagram here of some of these relationships. So if this is our person table, we have the person ID, which is a unique identifier for every single row in that table, every single person. And then we have a provider ID on there, which is the primary provider for that patient. And that links to the provider table on the provider ID variable. And so you could go here and then you could find out information about like, oh, what's this patient's primary provider's like specialty, or how old are they, or information like that, right? So we don't have to keep all this information in one giant sprawling table. We can keep it in the tables that are specific to that information and then link together easily as needed. Same thing with the location ID. So this is the primary location we have for this patient. But rather than storing all of the state and zip and address and timing information on the person table, we have it in the location table and then link with the location ID. Okay, one last thing about OMOP before we move on to more specific BigQuery stuff. So concepts, it's basically impossible to do anything with OMOP unless you have some understanding of what concepts are, because this is how OMOP represents literally everything. So any kind of information in OMOP is represented as a concept. And so, for example, something like the ICD-10 code E11.22, which is for type 2 diabetes mellitus with diabetic chronic kidney disease is given a unique concept ID of 4559577. You do not need to remember any of these specific IDs. You will always look them up. So because this particular code might not be unique across all different vocabularies, we have assigned, or OMOP Odyssey has assigned, a unique identifier in the form of the concept ID for any given code or idea or concept. Now, a standard concept is selected for each piece of information, and then there is a mapping between the original source concept and the standard concept. So different health systems might represent this, the type 2 diabetes with chronic kidney disease in different ways. And all of those source concepts will map to a single standard concept that represents like that actual idea. And so in OMOP, the standard concept ID for this is 435315578, which is actually a SNOMED code, so a different vocabulary than ICD-10. And you can see that like the underlying meaning, clinical meaning behind this code matches with what was in the ICD-10 code. So this just allows us to represent information coming from different health systems or different health vocabularies in one consistent way across the entire system. And that's one of the main benefits of something like the common data model. So you're not expected to know any of these concept IDs or codes. I recommend using Athena for easy search of these concepts. So this is another site here. You can search your keyword or you can search a specific code. So if I put in, for example, the ICD-10 code, because that's often what researchers know that I was interested in, I see a few different options here. I think I want the ICD-10-CM one. So I'm going to select it here. I get the concept ID, and then I also get the non-standard to standard map here. And then I also get some other relationships and information about how this code relates to other codes in the system. So this is what I would recommend doing when you're trying to figure out how is my particular clinical area of interest going to be represented in OMOP. There's something in the chat.
Oh, I just put the
Links.
link.
Okay. Perfect. Okay. Cool. So to try this out a little bit, not getting too much into the concepts, if our goal is to determine how old a certain patient is at the time of their most recent visit, what OMOP tables do we need to use and what fields do we need from each of those tables? So let me put in the link, the documentation. I should have. I want the CDMB 5.3 link.
I can put it. Give me a sec.
I think there we go. So if everyone can click on that link in the chat, or if you already know, that's fine too, and go through and figure out specifically what tables are we going to need to answer this question, and then what fields are we going to need from each of these tables. I'll give everyone like a minute or two, and then we can see what people come up with. Okay, can anyone unmute and or put it in the chat and tell me what specific tables from the OMOP data model we would need to use to answer this question?
Would it be person and visit occurrence?
Yes, sounds good. And then from those tables, because there's information on those tables we don't need, what are the fields or the variables or the columns that we will need to use from each of those tables? Someone else can answer too.
And it's perfectly, I mean, just think aloud. It's perfectly fine to make mistakes. I mean, that's why this is a working workshop. So, you know, we're all here to learn.
Age and days.
Age,
Age in the person table, the days in the visitor table.
can you put it in the
Let
chat? I think.
Let me pull up the data model again.
So I think you would need to compute the age though. So
Yeah.
you would want to know the date of the visit and the date of birth.
Yes. Yeah, so we do want the age, but we need things from both tables. So if we're looking at the person table, we have a year, month, day, or we could just pull the birth date time directly from here. Because this is for the person like throughout their health history, right? So we're not going to have an age at last visit on the person table. That's not something that's a property of the person. It's a property of the timing of the visit. So yeah, so we want to pull the birth date time from the person table, and then from the visit occurrence table, which field? We actually have a few date fields here. Anyone have any thoughts on what we should use?
Visit
This one, there
start
really
date.
isn't a right
Is
answer.
it start date or visit end date?
Yeah. So I would, in general, recommend using the start dates. One thing that helps, one thing that underlies that suggestion is that you can see based on the documentation here, which variables are required and which are not. And for this table, the visit start date is required. You'll notice the start date time is not required. And then here in the text, it says visit end dates are mandatory, but if end dates are not provided in the source, then they are derived in this way. So I do recommend using the start date just because it's the information that's pulled most directly out of the HR typically, unless you're specifically looking at like an inpatient visit that spans multiple days and you need to also take into account the end date. So
Now, does
yeah,
it make a difference because we're going to use date time for birthday and we're going to use date for start day? Does that make a difference?
Not really. I mean, if we're trying to figure out the age, I mean, we could be very precise and try to figure it out to the minute, but that's probably not useful for anyone. And we'll see when we actually execute this in BigQuery that BigQuery can handle dates and date time comparisons pretty seamlessly. So we can try both of them when we do this in a minute. How are we going to link the person from the person table to the visit table in order to associate their visit start date with their visit birth time?
We use the person ID field.
Yes, exactly. So if we look at this visit occurrence table, the visit occurrence ID is the primary key here. And you'll notice that that's actually explicitly stated for you in the documentation here. And then the person ID is actually the next field on the table because this is a person-centric database, remember? So almost all of these tables are going to have to link back directly to the patient in order for them to be useful at all for any kind of research that someone would want to do. So person ID is on here. It is required, so that's great. It's not the primary key, it is a foreign key, and the foreign key table is person. So this confirms that, but just by looking at the documentation. Cool. Okay. So let's go back to this. And then we'll send out these slides. So this is mostly for your own reference later, but we do have lots more resources on STARR-OMOP. There's documentation I keep pulling up. And then there's a lot more documentation on STAR specifically that's available for you. And we also have office hours and Slack channel and various other tools. Okay, any questions on OMOP common data model stuff before we move on to talking about Google BigQuery? Okay, awesome. So what is Google BigQuery? I Googled this when I was first making this slide because I was like, I don't know how to describe what Google BigQuery is. According to Google, it is a cloud-based data warehouse and powerful and set of powerful analytic tools. So it's feel like this should have, I don't know if this should have an S on it or not. But basically it handles a lot of the behind the scenes storage and optimization of your queries and allows you to like store your data there and then query your data, as well as providing, like a lot of other nice features. And it can be accessed a variety of ways. So you can access data that's stored in BigQuery and run queries on it through the command line. You can also do it using a BigQuery API if you're working from like a Jupyter notebook or something, or RStudio. And you can access it directly from the BigQuery console. And that's what we're going to be doing today. There's a lot of examples of accessing it using a Jupyter notebook in the tutorials for STARR-OMOP. So we recommend that you go look at that, or in the GitLab with all the NeroStar notebooks. So this will focus more on the console and the features that are available there for like quick exploration of what's available. And as a note, both storing and querying data do cost money using Google BigQuery, but it's not a ton for typical research needs, and there's ways to keep those costs pretty reasonable. So we'll talk some about that at the end. Okay, so I'm going to flip to the actual console and talk through this. So I'll have everyone do this with me. So if you guys all want to go, I did save this link, let me find it. Go to the Google Cloud console. This isn't necessarily where you would always start, but I just want to walk through the full process. So Google Cloud Platform is much bigger than just BigQuery. We're only going to use BigQuery today, but just to sort of situate you, we can go to the console.cloud.google.com. You'll notice that mine already specifies a project in the URL and also in this dropdown because I had already had this open and logged in. If you haven't logged in before, you should go ahead and do that with your stanford.edu email address. This is important because the project that is listed here, both in the URL and in this uppermost left dropdown, is basically the project that you are currently living and operating in. So that is the project that is going to be billed for the queries that you execute. And like that project needs to be able to have the appropriate permissions to access the data that you want, but it is not necessarily the same project where your data is stored. So you can be in one project and running queries from there against data that is stored in a different project. This comes up a lot when we're making sure that people have access to the data. So I just wanted to clarify. It's very easy if you come in from the screen because you see you're working in training project right now. So from here, we're going to go click the hamburger menu button here and go all the way down to BigQuery. Again, you'll notice there's like a lot of other stuff here, but we're just going to use BigQuery, and you can just click on BigQuery for now. And this is what it should look like. I hope folks are following along, and if you get stuck, feel free to send a message in the chat and we can do some troubleshooting. So from here, we have our Explorer on the left side and then our workspace on the right. And we'll start by taking a look at the Explorer. So one thing to note is that you can add data sets here. If they don't automatically show up, but you know you have access to them, you can click Add, go down to STAR project by name, and then put in the name of the project. And that will help make sure that the Google BigQuery is actually showing you that project. I already have my projects here and most of them are starred. We're going to be working in this training project today. So a little bit more situation here. These are the project names. That's sort of the top level of locating where you're at in BigQuery. Underneath projects, we have a few special cases here at the top, but mostly what we have is data sets. So first we are at the project level, then the data set level, and then at the table level. So we're going to be working primarily with this DID 1% light data set today. So this is what I'm going to be using. And you'll see if I click on it, it tells me data set info. This is the data set ID, which includes both the project and the name of the data set. And then a bunch of extra information about when it was created and when it's going to expire and when it was modified, some descriptions and things like that. Underneath the data set level, we have tables, and tables look like this. They have this little symbol that looks like a calculator to me. And if we click on a table, we actually see what the fields are on that table, and we can preview it. Oh, not that one. It's a good one, condition occurrence. We can preview our table and actually see our data. Yeah, so that's sort of the nesting structure here is our data lives in tables, which live in a data set, which lives in the project. If we look at the details tab on this particular table for condition occurrence, we actually see the full name spelled out here. So the first part before the first period is the project name, data set name, and then the table name. And that's generally all the pieces of information that you'll need to specify if you're querying data from a specific project. In this case, I am both working in the training project and querying data in the training project because we specifically set up this environment to be able to do that for training purposes. But often you will be working in your own, like your Neuro project is typical for most researchers, and then you'll be querying data that is actually in this SOM RAT-PHI STAR prod. That's our production environment that contains like the OMOP DIDs that are refreshed weekly. So you can be living in one project and querying data in a different one. More information that's available about the tables is the number of rows, which is a great thing to check. I mean, it'll be obvious pretty quickly if your table's empty, but it might be really small and you didn't realize that. So when you're sort of getting situated and figuring out what tables you want to be working with, it's a good idea to check how many rows are in that table and how much storage space it's taking up, just to give you a sense of like how long queries are going to take or how expensive they're going to be. The preview function is one of the best things about Google BigQuery, in my opinion, because it really allows you to feel like you know what is going on with your data really easily. So instead of having to set up a query kind of blind, just knowing the name of the table and maybe looking at the documentation, I can actually come in here and preview the data. This is not necessarily going to be like, it's not necessarily a random subset of the data. It's not necessarily like in the original order. So you can't really make a lot of predictions based on the specific data here, but you can see like what the format is and what's included. And I think this really helps just situate you to what's available in the data. So for example, I can see like, okay, well, clearly provider ID isn't filled out all the time. I don't know, it might be filled out all like a lot of the time for the rest of this giant data set, and it just isn't for the first 50 rows. I would have to like keep clicking through, but at least I know that it's not always there, right? And similarly, I can see that the condition start date time does have the time available, whereas the start date just has the date part, things like that. Cool. Any questions about the general context for where we're at in BigQuery? Cool. Okay.
Sorry, question. So for condition occurrence, is that where we'll find most of the tables that we would be looking at?
So condition occurrence is itself a table.
Okay.
There are other tables. All of these things on this left side at this same sort of nesting level are tables. Condition occurrence is going to contain occurrences of conditions. And so if you're looking for like diagnoses of a particular condition, that's going to be in this table. If you're looking for drugs that a patient is taking, that is going to be in the drug exposure table. And if you're looking for the list of providers that interact with patients in this data set, that is going to be in the provider table. So these are all different tables under this data set. And the data set is what we call like this data set level. That's what OMOP is. That's the relational database. And then all the tables underneath are linked together via those foreign keys, primary keys, things like that.
Gotcha. Thank you.
Yes, good question. Cool. Okay. So one other thing I wanted to point out, just because I think it can trip people up a little bit sometimes. So we have project data set and then table. There's one other kind of variation on that can happen. And it's actually called a view. And so a view functions like a table, and it's sort of at the same level of hierarchy, but it's not quite a table. It's like a potential table. And so first of all, you'll notice that the tables themselves have this darker outline of this like calculator shaped thing. The views have this like these black dots as the symbol next to them. Again, I still haven't figured out what this is supposed to stand for, but that's a clue that this is a view and not a table. In this case, I named them also, like I named this one view, but that's not always going to be the case. When we go in and like click on a view, the schema actually looks like basically the same as a normal table. If you go look at the details, this is the first clue that this is not a real table. There are 0 rows, 0 bytes of storage, nothing, there's just nothing here. But if we look at the bottom, we see this query, and this isn't there for most of our typical tables. So if I look at the condition occurrence table in the details tab and I scroll all the way down, there's no section for a query here. If I look at the view and I scroll all the way down, there is a query, and this is essentially the query that defines this view. In this case, I just spilled my tea. In this case, I built it to be just like a replica of the condition occurrence table from like an earlier data cut, and I limited it to just 100 observations. So I can run queries on this thing like on a table, and it will essentially behind the scenes recreate the table each time that I query it. But it doesn't actually exist and store the table unless I'm directly calling a query that is using it. So this can just throw people off a little bit. Notice there's no preview tab because again, it doesn't really exist. It's just a potential table. But I can use it in queries, which we'll get to in a second, the same way I would a table. And this could be an advantage because it doesn't take up any space in terms of storage, but it can help kind of keep your queries more organized if you've got a lot of stuff going on. Mainly, I just don't want people to get confused about the difference between a query and a view, because the OMOP _ latest that you'll see in the actual like list of OMOP data sets, that is actually a view and not a table, or it consists of views instead of tables. So quick side note on views there. Okay, so let's actually do some querying now. So what I want to do is our same example from before, except now I'm going to specify an actual person ID because we don't need to do this for everyone at the moment. So same basic principle. We're trying to figure out how old a patient is at their most recent visit. We already know what OMOP tables we need to use and what variables we need. But how do we actually construct this query to calculate the age at latest visit for this particular person? And the person ID here, I will put in the chat. Person ID, and this is like a de-identified person ID that corresponds to what's in the DID data set. So let's do this together. So hopefully you've all are in BigQuery in GCP. So if you followed the link I sent just before this to the console.cloud.google.com, you can then go to BigQuery from there, or you can go directly to BigQuery if you have that saved. Make sure that you're working in the SOM RIT STAR training project by using this drop down up here if you aren't already. And then we are going to be using this, this data set. So I'll go ahead and put this in the chat as well. You can copy paste this. So if you have this link, you can put it in the search bar in the Explorer and it'll automatically bring up that data set for you, which is very handy. So I'll give folks a minute to get themselves here. And if you don't currently have access, you can reach out to us after and we can help make sure that you get that set up. But for now, you can just follow along with what I'm doing on the screen, or you can try this on a different data set if you have access to something different. So we already talked about that we'll need the person table and we will need the visit occurrence table. So what I like to do in BigQuery is actually use this, this option that they have available. Again, this is just something that makes it really easy to set up a query. I go to the table that I'm going to be querying, one of them at least, and then I hit this query like drop down with the little bar here, magnifying glass. And then I can choose if I want to do it in a new tab or a split tab. Since I have a big monitor, I like to do it in a split tab so I can still see the table and the fields that I'm querying, but you can also do it in another tab and it'll just open it up right here. if you don't have as much screen space. So what this does is it opens up essentially a new workspace with the sort of outline of a query for that table. And you can see we already sort of have something that looks like a SQL query here, but it's missing some important stuff. So it's actually already telling me up here in the right, there's a syntax error that select list must not be empty. So I can't query nothing from this table. So I could just put star if I wanted just as a placeholder. I'm just gonna space this out a little bit. So this would be like a very basic query where I would just pull 1,000 rows from the visit occurrence table. That's not actually what I want. So let me go ahead and put in some of the fields that we had talked about earlier. So I know I'm gonna need person ID, and I know I'm gonna need visit start date. Cool. Okay, and then let's go ahead and run this just so that we can take a look at it. So I just hit run up here, or you can highlight it and hit Control Enter. Any of those work. And so I haven't restricted this to the person that I specified or done anything else with it yet, but just as a basic query, I just selected these particular fields from this table, and I can see them here, and that's great. There's also some additional information here, so I can get these results as a JSON if I want. I can learn more about the job and like how much was billed and things like that, and some information about how long it took, things like that. But primarily, you're just going to be looking at the results tab, and that's what's pulled up for you automatically. So we have our person ID and our visit start date. Let me go ahead and restrict to the person ID that we that I said we were going to focus on. So I'll add a where condition here equals nope. And then I'm not going to need the limit if I'm just restricting to that. So let's just do this and double check. Okay, so technically I could take off this person ID, but it's kind of nice to have it as a check here just to make sure. So this particular person has 3 different visits that are listed here. 2 of them are on the same day. And then one is like, what, 7 months later. Cool, so are people that are following along able to replicate something along these lines of querying the visit occurrence table? Can put
So what
like
would
a yes in the chat, something like that.
what would visit dates on the same day for the same person mean?
So essentially, it just means that there were multiple different encounters that were listed in Clarity for that person for that day. It could mean 2 different instances of what we sort of think of as traditional visits. So maybe they came in for an appointment, and then they came back in later for like a scan or some blood work or something like that. There's also things that are included as an encounter that are maybe less traditionally what we might think of as visits. Things like orders for a particular medication or procedure might be in there, or other kinds of interactions, like maybe there was a phone call first and then there was an in-person visit, something like that, and those would show up as separate encounters. So yeah, there are many different situations where we would get multiple encounters on the same day.
If you wanted to reduce that, you can just do the distinct, select distinct, and then you will just get the date once for each unique row.
Yes, yeah, so if I don't care about the separate visits, like I'm not interested in characteristics of those visits, I just want to know what the dates were that this person interacted with the healthcare system, I could just select distinct person ID and dates. And for our purposes, since we're trying to calculate age, that's fine, right? We don't care about what the person was in here for, what providers saw them or anything like that. We're just looking at the dates, so we can go ahead and add that. Cool, okay, so we have our visit occurrence table. We need to join this to the person table in order to actually find that birth date time. So we're going to do, I like to do a left join by default because I think it's the one that makes it the most obvious when things don't go the way you expect. But there are a variety of different kinds of joins you could do. You could do an inner join, an outer join. left join, right join. And I will not get too much into the SQL today, so you can feel free to Google those options if you want. I'm just going to recommend a left join. And then I typically just copy the name of the table and then change this last part, since most of it's going to be the same. I want to make sure I'm always working with different tables that are from the same data set, like the same data cut. Unless I'm doing something very specific, I don't want to be working across two different data cuts usually. So I'm going to left join on the person ID. Again, there's multiple ways that we can do this. I'm going to show like what I think of as a good default way. So I'm going to give nicknames to both of my tables. That's maybe longer than I would typically give, but I think it makes it more readable. ID. So I'm telling BigQuery what field in each of these tables to use to join on. And you'll notice that as I was typing this, Google was trying to be helpful and filling in, like suggesting different variables that start with those letters. So there's a variable person source value, and it even tells me what kind of variable it is, like whether it's an integer or a string, which is so helpful to know that ahead of time rather than having to go back and double check the schema. Of course, it's also right here, but this will make sure that you're getting your types lined up properly. So again, another really nice feature. So we're going to join on person ID. So now I'm getting another error. So again, error checking, amazing feature of Google BigQuery. So instead of having to run your query 14 times in order to fix all of the errors, it will just tell you right away. So it's saying that the column name person ID is ambiguous. In this case, this is kind of overkill because the person ID is definitely going to be the same because we joined on it across these tables. But in general, we do need to specify which table we're referring to when there's a variable that's on multiple tables. So I'm going to go ahead and just pick one. In this case, it doesn't really matter. And then I'm going to have to do the same thing up here. Okay, so now this is happy, but I don't actually have all of the variables I want. So let's actually see that. So I can run this again. I'm like, okay, great. I joined on that table, but I didn't pull out any information from that table. So it's not actually any more informative than it was before. So we need to pull out the birth date time. And you can see again, it's suggesting once I start typing. I am going to add actually the names of the tables to both of these just as a good practice, because I think it's really helpful. If you end up doing more joins or making your query more complicated, it's a lot easier to be able to see which tables these things come from. Okay. Okay, so now we have the birth date attached to this. You'll notice it's the same for both of them because obviously this single person is going to have one birth date regardless of when their visits occurred. So now we have all of the pieces of information we need. Anyone have any suggestions on how we can calculate the actual age? I mean, we could just like subtract, like type this into Google, like a Google search if we wanted to, but if we wanted to make BigQuery do this for us, how would we calculate the age for each of these visits, or for the max visit, if that's what we wanted? Even if you don't know like a specific function, you can just say the general thing that you're trying to do.
How would you do it if you were actually going to do it on a calculator or do it by hand? What would you be doing? How would you do it?
In Excel, we use day difference.
So let's see if there's a function like that in BigQuery, right?
Yes. So I'm actually going to do even a slightly more simplistic approach first. And I'm just going to say what happens if I just say, let's see, I want to subtract the visit birth date from the birth date time from the visit start date. Right, so this is like approximately what I want to do. It's not quite subtraction, but I want to find the difference between the two of these things, right? So let's try this first, and then we're going to find a more specific function that will also do this. Cool, so notice I basically added another field into my query and into the select statement here. I didn't tell it what to call this, and this is like a combination of multiple different variables, and so Google BigQuery gives it like a placeholder name in the output, which is this F and then a number, and it will continue to advance if I add more unnamed things to the select statement. And it looks like this. Anyone have any guesses what this format is? What about just the first part of it? Or maybe just the last part of it? What does this part look like?
Time.
Timestamp.
Yes, this looks like a time, just not a useful one. So what do we think this part is?
Days.
Yeah, so this is years, months, and days, but this difference was just calculated in days. So technically this gives us the answer we want, but I think if you ask someone how old your patient was and you told them 23,817 days, they would not be very happy. So we can add some more levels of sophistication here. So I'm gonna go ahead and leave this and I'm gonna call it as, let's see, age at visit. And let me actually just show, since I'm adding more things, this query is getting a little bit harder to read. So I'm actually going to do this format query thing, which is again, something really nice that BigQuery does. And so notice that it like makes this much more readable by just spacing it out according to its automatic process. So, okay, so I have my like crude calculation of the difference as age at visit, and then I'm gonna add another, basically the equivalent of the date diff function, same, I believe it's also actually called date diff. Yes, so there are lots of different date time functions in BigQuery. I encourage folks to look at the documentation and we can pull that up in a sec. And so for this, I just need to specify the end and the start. And then I need to tell it what the units are essentially. And so I guess actually let me do days because, and then we can compare to what we had before. Maybe it's just day. Great, okay. As days. So right now I'm telling it to calculate the difference between these two dates and I'm telling it to give me the answer in terms of the number of days. So if I run this, I'm thinking it's going to match, yeah, it's going to match the day part of what we had before, but it's just formatted a little bit more like what we would expect. Now, typically we report people's ages at least when they're this many thousands of days old in years. So I'm going to switch the unit and say age in years. Is it? Cool. And now we get something that's a little bit more human readable. I think my original question as I wrote it was talking about the max age, but in this case, since this person was the same age in both of these visits, we can just go with the 66 here. So real quick, just to look at the documentation for this function, if you just search BigQuery and then date functions, you can get a list of, you can see I've searched this many times before. You can get this list of all of the different date functions that are quite nice. I like going directly to the actual BigQuery documentation to see what functions are available, but I don't think their descriptions and examples are always the best. So you can also just Google like BigQuery date diff function and find examples on like people's blogs or people's, you know, whatever, lots of people do this. One note is that BigQuery SQL is a little bit different from other SQL dialects, or at least some of the other SQL dialects. So I do recommend searching specifically for BigQuery SQL and not just SQL, because sometimes there's little things that are different. It's pretty close to standard SQL, but it's a little different from like the Microsoft version and things like that. So just something to keep in mind that there are different dialects and you want to find the BigQuery version of that. Questions on this example? Or anything else we talked about?
Can you please add the link to the BigQuery functions onto the chat?
Yeah.
Thank you.
Like I said, I pretty much always get to it by just Googling, but you can also get to it, you can also save this. I guess we would go from maybe here. And then there's all these different functions that you can look at. Okay, so that is our first example. Let me see where we're at. Let's see, do I want to do another example first? Yeah, let's do a slightly more interesting example where we're doing some aggregation as well. So this is one example, and okay, other things that you can do. So you can save your queries or you can save your output or both. So if this is a query that you think, oh, this is super useful, I might have to run this again, or I might want to use this as an example again, any of those, you can go up here and click save query, and then give it a name that's hopefully better than just the timestamp. So I might call this get age at visit. By default, it's going to be in this personal visibility, so it's only visible to you. So that's typically what you want. And you can hit save. And then first of all, it names your tab, which can be great if you're just trying to keep yourself organized and you have too many tabs open, but it also shows up under the saved queries, which is like the first drop down under the project. So this is a project level characteristic as your saved queries. And you can save a lot. I think I have like 40 or 50 in some of my projects that I haven't hit a limit yet. So I think you can just keep saving them. And that's really useful. So you can close BigQuery, restart your computer, whatever you need to do, and come back and reopen that query and hopefully find it easily. If you want to save the output as like essentially as a table that you could then query, you can't actually create a table. So we could do the traditional SQL of like create table and then list out the project name and the data set name and the table name and so on. And that would actually create a table, or we can save this as a view. And so we still have to specify like all of the information to get like the very specific location, but this will essentially allow you to query your output as another table in BigQuery. So I do that much less often. I think saving the query is typically the way to go because you can see like a lot of queries run very fast, especially when you're running it on the 1%. And so you might as well just rerun your query after making any tweaks that you need. But I did want to note that those are both options that are available. So, okay, so I've saved this query. I'm moving on. I now want to do something different. Something that I do like constantly is get counts of things that are happening in the data set, and I want to group by a specific variable. So for example, the year 2020 is a very interesting year health data research wise. I think it's interesting to look at the number of visits per month in 2020. And this gives us like a very sort of high level crude glimpse into the impact on healthcare utilization during that year. So what we're actually going to do to do that is we're going to start again from the visit occurrence table. So let me just grab my query and say, I'll do this again in the split tab. So now I'm again going to use the visit start date from this table. And then I want this to be in the year 2020. So there's different ways I can do this. Another date function that I think is super helpful is the extract. So I just want the year here, and then I want it to be equal to, I don't think I need, yeah. So like this, I wasn't sure if it should be a string or an integer. I was like, I think it should be an integer, but like if I had done this, BigQuery would have complained about no matching signature for operator equals argument types. And I know this is hard to read. Let's see if we can. So it's telling me that I'm trying to compare an int64 to a string here. So I can't do that. So then I'm like, oh, okay, this definitely has to be an integer. So I'm going to go ahead and just run this. So something that I want to show here is the process of building up a more complicated query in BigQuery. And so I'm going to start from sort of like a really simple one. So I'm like, okay, I know I need the date and I know I need this where condition. So let me go ahead and do that and look at the data. I'm like, okay, all of these say 2020. That's great. This means this is doing what I want. And also there's like, well, there's 100 because I said limit 100. So good starting point. Now what I want to do is actually get just the month out of these visits and then group by that. So I'm going to use the same function and say extract month from visit start date. And then I'm going to count the rows. And I'm going, well, if I don't do anything else, it's going to complain and tell me again, what was it telling me? Yeah, so it's telling me that there's this column here and I haven't grouped or aggregated it. So I told it that I wanted it to count something and it's expecting a grouping or an aggregation. I haven't told it what that is yet. So what I'm going to do is add this group by to the end of my SQL, and I can add this shortcut to say the first thing that I said in the select statement, use that. I could also just copy this whole thing and put it again down here. Let me start with that. Yeah. So let's go ahead and run this. Okay, so again, this is my first pass. I'm just gonna, I'm trying to add in like one thing at a time and then run it and take a look at what I get and see what I need to adjust. So does anyone have any suggestions about how I can refine this to make this look more helpful or readable? Because technically I have kind of what I asked for, but it's not really very easy to see any patterns in this yet.
I think you want to sort or order by the month.
Yes, I agree. So I'm going to add another clause to my SQL and say order by, and now I am going to switch to using this shorthand just because I think it's easier to read. So I'm going to say I want to both group by the month and I want to order it by the month, so it's in the order of like the calendar year that we would expect. Okay, better. What about the names of the columns? I mean, in this case, I feel like it's pretty straightforward because these numbers are much smaller than these numbers, but anyone have suggestions about how I should label these?
Just call it month and counts.
Visits, visit count.
Visit
Yeah.
counts.
Yes. I have a strong habit from my last job of using n underscore as the prefix for all count variables. So I continue to do that here, but I like calling it visits. So I like specifying that this is a count because that's not always obvious when you're coming back and looking at your output later. And I do that with the n underscore. And then I also like specifying the units because I could have counted this by like unique dates or something else like that. And I didn't do that, right? This is counts of visits because that's what was in this table originally. So I agree with specifying both that it is a count and what it is a count of. Cool. One other thing that I think in this case is like maybe not as obvious, but that I like to add is actually the percentage of the total that falls in each month. I think often the percentage is sort of easier to see patterns in than just the raw count. And so what I like to do, this is like, looks a little bit complicated. So the issue is that I have grouped by months, but I want my denominator for my percentage to actually be everything, right? Not just the months, not just within each month. And so I actually have to like re-aggregate to get my denominator. So I have this really ugly looking partition thing to basically, so the count star is just the same as the number of visits. And then the denominator I do is I sum over all of those different things in the entire data set. And so this will give me my percentage or proportion in this fraction, in this case, across the different months. So I think this does make it a little bit easier. You can also kind of see it in these values, but you can see that in April and May of 2020, we had like lower sort of utilization or lower a number of healthcare visits than before and after, and then it did like rebound to higher than what it had been before. We kind of expect increasing numbers in general just because we have more and more patients, but we would have to like compare to other years to see if this was a typical pattern or if this was being driven by the pandemic beyond the original few months here. So I just want to do a group by example and like accounts and group by, because I think that's super useful for understanding your data and making sure that the overarching patterns in the data set align with what you expect, because you can't go through and look at every single observation in your data set. But you can do something like this and aggregate to a level where you have an expectation about what's going on in your data set and use that. Cool. Questions on any of these queries? Okay, so we're going to take like a 5-minute break-ish, maybe a little bit longer. We'll come back at 2:15. And when we come back, we'll do like a little bit of a more involved example where we start by like looking up what concepts we need and then go from there to say like, oh, how do I find a particular kind of condition in OMOP? If anyone has any questions or any like research questions or things that they would like to be able to do with OMOP using BigQuery, please feel free to brainstorm and come back with that, because we'll have some time after that to do any other kinds of questions that you all would like to do. So I will see you all back here in 6 minutes at 2:15. Okay, give everyone a few more minutes or a few more seconds to get back, and then we'll get started again. Let me just pull up a few. Okay, so if you don't already have Athena open, I recommend that. And then we will be going through another example. Okay. So the next thing I want to go through is sort of the full process of if you have like a particular condition that you're trying to do a study on, or potentially a particular drug or something else like that, how would you go about finding that thing, that clinical event in OMOP? And there's a few steps to this process, mostly because everything in OMOP is represented as a concept ID. And so the first thing that you'll want to do is, well, figure out what table the thing that you're interested in is going to be in OMOP. For this example, we're going to be looking at diagnoses of AFib. So let me see. And this is just an example that someone had brought up last time. Does anyone actually have another condition that they would be interested in looking at? together here, just like the name of the condition or something you're working on studying.
Can we check on LGS?
LGS.
Yep.
What's the full like name for that? Because I don't think this is.
It's a Lennox-Gastaut syndrome.
Lennox.
NNOX. Lennox.
Double N.
Gastro.
Dot.
Gast what? Let me search this and see what happens. Aha. Great. Love Athena. You can see that I do not have a clinical background. I have a data background. So great. So this, I assume, is the thing that you're talking about. You want to tell us a little bit about what this is? I'm very curious now.
It's a type of epilepsy.
Okay. Interesting. Okay, so is it related to, what is this pseudo-Lennox syndrome? Do you know what that is?
Totally not sure. I
Okay,
never read pseudo at all.
Okay, so let's see. So here's the name that we're looking for, and I'm assuming we want to look for something that's a condition. You can see we have a few different things. We also have like a drug here, which I assume is something that's related to treatment of that. So I'm going to click on this one. This is very much part of the process of like exploring how to find this data in OMOP. So the original concept I clicked on was a heading concept, and it was non-standard. So that tells me that that is not going to be in the condition concept ID, which is sort of the main identifier for the condition table. But I can use this non-standard to standard map and say, okay, this to me at least looks like the same thing. There's just a dash, which I hadn't put in my original search, and it's a disorder, and it's a standard code, and the start and end dates encompass the current date, so that's great. So let's look for this code in our data and see what we find. We can also see like some other things here that it's related to. So here's a finding site status. Oh, see, this would have helped me understand a little bit more about what it is. So there's all these different hierarchies and relationships between the concepts that it can be useful to look at. Here's also a list of all of the non-standard, so like other kinds of vocabularies or definitions that map to this same standard concept. So I can see like, okay, in this vocabulary, in the Nebraska lexicon, I don't know what that is, it's called this, and this is the concept ID. And here we have some more specific things. So like if we had like a list of ICD-10 codes, then maybe maybe this ICD-10 code G40.813 would have been on our list. We could have come looked that up, seen again that it was non-standard, and then gone to the non-standard to standard map. You can actually see here that there are multiple different standard codes because this ICD-10 code has like different parts to it. And so in that case, you might either want to look for a combination of these codes, or you can use your judgment to say, well, I'm really just looking for this particular one. So there is sometimes some discretionary stuff to figure out what exactly you're looking for in the data. I recommend going broad first and then narrowing it down once you figure out what you're looking for. So let's try this one. So I want the concept ID, not the concept code necessarily. The IDs are how everything is stored in OMOP. I'm going to come back here. We're going to look in the condition occurrence table. I personally, when I work, I keep all of the data sets and tables on the left side, and I keep my queries on the right side because that keeps my brain organized. You can do whatever works for you. So let's take a look at this because we haven't spent a bunch of time working with it. So we have the condition occurrence ID, which this is a condition occurrence table. So this ID is the unique primary key. So there's just one unique value per row. That doesn't really contain any clinical information. It's just the reference. Person ID is useful if we're trying to link this to other information about the patient. And then the condition concept ID is actually what contains like the condition as you would think of it, or the diagnosis. And then we have the start date and so on. So I'm going to look in the condition concept ID. Something else I just realized like a few days ago is I can click on a particular field in this table and it'll copy it to my my thing. I feel like that's not that much easier than typing it, but something else that it tries to help you with. Okay, so I'm looking for condition concept IDs. And again, when I start out, I always want to just do like the most basic thing. So let me actually just get a count of how many conditions there are where I think I copied something else since that last thing. So let me go back here and grab this again, where the condition concept ID is equal to this. So let's see if we have anything. Hey, there's 59 rows. Great. Whenever I ask for examples, I'm always like, oh, I hope that really is in OMOP. Okay, let's take a look at these. So 59 is like a reasonable number, right? So I'm like, I can like look at all of that data. So I'm going to do a select star, which is pulling everything. So I don't recommend doing that unless you've already checked that you're going to get back like a reasonable amount of data. So let's do this and take a look. Okay, so the first thing I'm noticing is that the person ID is the same for at least a lot of these, possibly all of them. Oh, not all of them. Okay, great. So does anyone want to take a stab at explaining why we might see the same person ID multiple times in the condition occurrence table for the same condition?
And on different dates.
Yes, that's a clue.
It could be problem list associated with a medication or a procedure. It pops up in the chart in a lot of ways.
Yeah, definitely. So it could be multiple ways of recording the issue, even on the same date, actually. So like in this case, oh no, those are a year apart. It's possible to get the same condition on the same date for the same person. We also would just get like, especially if it's something that's a chronic condition or isn't resolved quickly, then every time that person comes in for care and that condition is relevant to that care, that diagnosis is likely going to be recorded in their record again. So for some kinds of conditions, you wouldn't really expect to see a lot of different rows, but for a lot of conditions, it's pretty common to see that condition continue to pop up in that patient's record. So again, if we wanted to see not just how many condition occurrences there are, but actually how many unique patients there are with this condition, how would I change this query?
Distinct.
Distinct what?
Person ID.
Person ID.
Yes, distinct person ID. So we have 3. So that's a good reminder that whenever you're looking at something that isn't the person table, it's not necessarily going to be at the level of like the number of rows isn't going to correspond to the number of patients. And so if you're trying to see how many patients have that condition, not just how many times has that condition been recorded in a medical record, then you're going to want to check the number of distinct patients.
And you said go ahead, finish.
I was just going to say, so it's important which variable we choose here, right? We can't just say select distinct. If I had said select distinct condition occurrence ID, this is going to tell me 59 again, right? Because the condition occurrence ID is just a unique row identifier for the condition occurrence table. So I need to make sure I'm thinking carefully about what unit I'm really trying to count when I'm doing this.
And again, that's three out of the 1% light data set.
Yes, that is correct. Yeah, so this is the 1% light data set. There's likely more in the full data set.
Yeah, so the 1% light is what, 35,000 patients out of the 3.5 million, right?
Yeah,
So
we can check that, right? So the person table is at the level of the person. So if I go to the person table and I look at the details, I can see, okay, 35,972 patients in here. And yes, there are way more patients than that in the Stanford health system in general. Hopefully like 100 times as many, given that this is the 1% data set, but we'll see. Okay.
Can we try to add multiple concept IDs rather than just having one?
Yes. Yes. So if we want to add multiple, we could say well, we could say equals this or equals this or equals this, which is kind of annoying, or we can say in and then do a list of the different concept IDs. So I'm going to make this up because I don't know what the next one is, but I could say something like this. And then that would return, you know, the equivalent, but for both any of those. And I could extend that to as many as I want.
You mentioned something, Natasha. You said don't do a select star or unless you know how many there are going to be. And was there a reason why you said that?
Yeah, I think a select star is like an easy bad habit to slip into because it's kind of nice to just be able to not think about what to put in your select statement and just be like, just give me everything. But OMOP is big, like especially if you're not working with the 1% data set and you query like everything and you ask it to give you all rows and all columns from a data set. That's a lot of data and that is going to be charged and it's going to take up querying time. So I think it's just like for a lot of data sets, it's not going to be that big of a deal, but it is good to get in the habit of thinking a little bit more carefully about what you're putting in your select statement and really keeping it to just the information that you're trying to work with. And if you want to get like just a broad sense of what's in your table, then the preview function is a great way to do that.
And it's because it's really important, like people come back to us later and say, hey, why are my bills so high? Or how can I optimize my query? And that's one of the first ways you would optimize your query. Like, don't get into the habit of doing a select star. It's really easy, but BigQuery charges you based on how much data it has touched. So if you do a select star, it's going to touch all the columns in all the rows. So.
And how much is that? How much data will that use?
So if you do a select star, you can see how much data will be on the right.
Yeah, so you can see it up here every time. And then you can also just see how big the data set is here. So this actually isn't that expensive. I have a slide on the cost, which I will actually, yeah, why don't we take a little detour and talk about cost?
Sorry, didn't mean to derail it.
No, I think this is useful and I had intended to do it before the break, but it got distracted. So the cost is $5 per 1 terabyte of data that you touch in a query. And the first terabyte per month per project is free. So a lot of our queries like that we're currently running on the 1% DID data set are more in terms of megabytes than terabytes. And so there's something like this much of a dollar. And so they're very, very cheap if you are running on the 1% data set. If you start running on the full OMOP and you start querying all of the rows, then that gets expensive. So I queried like the entire condition occurrence table, or if I queried the entire condition occurrence table from the DID 1% light, that would be 145 megabytes, which would be 7,000th of a cent, right? So it's pretty cheap at that level. It's just if you start doing too much with the full OMOP and like repeating a lot of big queries or doing a lot of select stars that it starts to become an issue. Yeah, the preview functionality is free, so that's your friend. Make sure you're only selecting the columns you need. That'll also help just declutter your workspace. It's hard if you have a ton of variables there to see what you need to see. And you can store data in temp tables. Like if you keep running the same query to generate your cohort again and again and again, at that point, it's going to be more efficient to just create another table with your cohort and just use that rather than touching all of the original tables to create that cohort. So there's plenty of ways to keep the costs low. And yeah, it's actually like pretty cost efficient if you're being a little bit mindful about it. And there is a reference from BigQuery about best practices for that.
And like the preview is nothing but a select star limit to something, right?
Yeah, I actually think that the select star sometimes is, if you just select star on the data set, I think that is free. Let's go test. So like if I just select star, I'm going to highlight this, and so it'll give me the estimate for just the highlighted part.
So, but if you do a preview, the preview is free.
Yeah, I kind of thought the select star was too, but I'm not sure.
Do a limit to usually 1,000.
Yeah, so the limit doesn't generally change how much data is touched. That just changed how much data is displayed in the output.
Correct.
But I thought, let me run this and see what happens.
What's the highest somebody has been billed at now?
So I can tell you that there was one lab that actually they started a VM, a pretty big virtual machine, and then they went on vacation. So so that was one bad, not so good incident. The second another incident was actually it was in a for loop that got stuck, and they didn't realize because they were just waiting for it to finish, and it didn't finish for a few days. But the good thing is that when you work with SRCC, who are the folks who give you your Neuro project, you can actually ask them to put like alerts. So every time your bill goes up by say $50, you're going to get an email notification. So you can set up alerts.
Cool. Don't want the dictionary for 146. Yeah, so even just querying select star, what it does look like it charges me for the full amount there, whereas I can essentially do the same thing in the preview functionality for no cost. So
Correct.
use the preview. Any other questions on cost stuff before we keep going with our?
So there's a question, are we allowed to use practice and start training BigQuery project? So the answer to that question is yes. When you sign up for the tutorials, which is a sort of a bigger overview, Natasha's sort of diving deep into one part of the tutorial, that sort of goes into the concepts, there are 4 tutorials. So we walk you through how do you access BigQuery, how do you get your GCP project, then all about the OMOP vocabularies, and then how do you use Atlas, and then how would you actually query the notes. So those are the 4 tutorials. If you request access to the tutorials, part of that is you will get access to Neuro BigQuery, the training project for 3 months.
I was gonna pull up the YouTube just so folks can see what this looks like. So yeah, there's a lot of videos on this channel, and then there's the tutorials
Yeah.
in the playlists, right? Tools for healthcare data science, tutorial 1, tutorial 2, 3 is Atlas. So I don't want to play that, but yeah, so there is a much more detailed overview of a lot of the stuff that I covered today. So these videos, and these are available to anyone. Okay, back to our example. So, okay, we were looking at people with this particular condition. Okay, and we found that there was only 3, so this was a fake ID that I made up, I think. So we found that there were only 3 people with this particular concept ID. Let's go back and look at Athena and see if we maybe go up a level. So for example, this is like a classification. So this is a particular kind of epileptic encephalopathy. So I'm going to go ahead and see if we look at this concept ID, just so we can have a few more examples to play around with. You might not want to do this for your particular research needs, but let's try this one and see person ID. Nope. Okay. We don't have anyone with that particular concept ID. So I don't really want to get into the concept ancestors. I don't think there is a way to say like anything under this general umbrella, but for now, I think we'll just use what we had before for the particular syndrome. Okay, so we have our few people, and then what I was thinking was, so we could restrict, if we had a certain study period, we could restrict our data to just that study period using a where condition. I think we've looked at doing that before, so I'm going to skip that aspect. And then we can count the number of diagnoses per patient is sort of an interesting way to look at this. So we know that there's 59 total occurrences of this condition. We know that there's 3 patients, but we might want to say like, okay, not just on average, but like actually how many times does this occur for each person? So let's go ahead and construct that query from here. So I want to have the person ID and then select them on this, where this, and again, I'm going to do a count. And I'm going to count the condition occurrence ID. I could also count star since this table is the condition occurrence table. And I'm going to group by 1. So let's see from just this where we get. Okay, so like this is a more nuanced view than what we had before, right? We have 2 people that each had 2 instances of this, and then we have 1 person that accounts for almost all of the 59 instances. So this is the kind of information that is really useful as a researcher if you're trying to see like how feasible a particular study is in our data. Knowing something like this might be quite helpful. We could also say like for this person, what is the latest condition start date that they have this particular condition. So, okay, this person, it was in 2021, and then these 2 people, it was both in 2022. I could also add like the min, so I can see what time frame this was over. And this is all grouping by the person ID because that's sort of the level I'm interested in right now, is saying, okay, for each of these patients. If there were more patients, we might want to do an additional level of aggregation. But since there's only 3, it's pretty easy to just review this this way. So, okay, so this person had this condition continuing to come up in their record between 2016 and 2022. This person, it spanned 3 years, and this person, it spanned just a few months. For the folks that suggested this condition, are there any other things, like any kind of maybe like drugs that might be used for this, or procedures, or other kinds of things you'd be interested in checking for these patients?
I would like to exclude patients who underwent chemotherapy. A patient is LGS, and patient shouldn't be underwent any kind of chemotherapy for the entire lifetime.
For their whole lifetime. Okay. So chemotherapy, I think, is kind of an interesting one. It's quite a broad category. And I'm actually not sure off the bat if it's better to look in the procedure occurrence table or in the drug exposure table. And we might need to check both. Priya, do you have any insight or suggestion on that?
It sounds like, if I understood you correctly, you said you want to exclude patients with certain kinds of chemotherapy. Is that what you?
Yeah. I want all the patients who have LGS, but the patient shouldn't have underwent any kind of chemotherapy in their entire lifetime.
So the best way to do that, I would say, is I think the best way to actually do that would be an atlas, where you create the cohort, you put in the conditions you want, and then you actually create a condition that has not had whatever. So it's really nice to create. And what is really cool, and I think really nice about Atlas, is that it creates, it's a GUI, but you can actually go access the SQL. So then when you go access the SQL, then you can actually refine that SQL, because then you can go put it in the BigQuery GUI. But you can use Atlas as your starting point instead of trying to break your head to figure out how exactly to do that. Does that make sense?
Okay, yeah, that's helpful.
Yeah, so I think for this particular task, that's probably going to be a lot easier because there's going to be a lot of codes under chemotherapy. So it's important when we go look at these codes to remember that, like, even though this is a standard concept, like especially for something like this, probably this doesn't just get billed as like chemotherapy. It probably gets billed as something specific. And so we want really like everything that falls under this category, and maybe you'd want to review that more and like think, okay, those kind of types don't count for this. We're going to exclude those. We're going to include these. So this is something that's possible to do directly in OMOP using the vocabulary tables. Let me just show those really quick just to give a sense, but I think Priya's right. Atlas would be a better way to approach this, and that's sort of what it's built for. So this would be more like if you're trying to explore that definition a little bit more, you could come back to the OMOP data, or once you have the SQL from Atlas. So if we did want to look in, so So I said I was going to do the vocabulary table. So the concept table is what would have like the main ID for that chemotherapy code. So I found chemotherapy, like a very generic code in Athena, and this concept ID. I could take this concept ID and go to the concept ancestor table, and I could give me all of the descendant concepts for where the ancestor concept ID is this broad chemotherapy code. And ideally, depending on quite exactly how the hierarchy is set up, ideally that would give me a lot of those sort of subcodes that fall under chemotherapy. And then I could use those to go look through the procedure occurrence table, or whichever table I was looking for.
What's really cool in Atlas is it's really just a checkbox. You say, yes, I want this code. I don't want this code. I want this code. I don't want this code. So it's much easier to do because you would make mistakes like typing this up, which is why I would recommend use that as a starting point. And another thing, and you may have mentioned this, and again, like we don't want to go into too much detail, but the tutorials do talk about how you would sort of play around in Athena. But if you look in Athena, because if you're wondering what these ancestors and so on are, if you look in here, there's a hierarchy button. So that kind of tries to do it visually for you. So it's really like a tree. So under chemotherapy are, these are all sort of children of chemotherapy, right? So they're more specific versions of the types of chemotherapy. So it's probable that at Stanford, nobody's just built for chemotherapy. They're going to be built for one of these.
Okay, yeah, that's helpful.
Yeah, so there's lots and lots of different ways to kind of approach this. And we want you to be able to use, Atlas probably for the actual, like forming your specific list of all the things you want to include. But something like this can help give you a sense of what kind of codes you're looking for. And you can check in the data to see like, oh, actually Atlas will also tell you what codes are common at Stanford and which ones aren't used.
Yeah.
There's like a record count. So that's super helpful too.
So there's an Atlas tutorial happening 2 weeks from now. Sorry, I couldn't resist that sound
No,
bite.
that's fine. Cool. Yeah, that's part of the like family of tools that are available that are very helpful for dealing with all of this. Okay, it is 2:45. Anyone have any other questions about like Google BigQuery OMOP stuff specifically? No? Okay. Cool. So let's just talk briefly again about what other resources are available to you all. Let me just pull up my thing again. So yeah, we already showed a little bit the YouTube channel that has, first it has prior workshop recordings. It will have this workshop recording eventually. And we will also send out these slides, and I have saved the queries that I used for examples under the like project level saved queries in the training project. So you'll have access to everything we talked about today. If you want to do the tutorials, you can email star-omop-support@stanford.edu. This is our new support email. You can also create a ticket directly in the web form here. So that's the best way. If you're having a particular issue with getting access to something, or you need our team's help with some aspect, that's the best way to contact us. There's also a bunch of example Jupyter notebooks. So at the beginning, I mentioned that like we're just going to focus on the console for interacting with BigQuery, but there's other approaches. Jupyter notebooks are a great way to go if you're trying to like save a specific process, or you want to add commentary on like, okay, after I saw this, I went on to this step and so on, like so that you can walk someone through your sort of process. I think of the console as more like the like exploratory playground, right? And like sure, you can save queries, but it's really more for like quick and easy data exploration. Jupyter notebooks are a great way to have a more permanent record of what you did that's still like dynamically able to access the data.
And
There's
quickly,
also,
actually, for this, I wanted to say, like, when you sign up even for the tutorials, or when you actually get access to STARR-OMOP DID, you automatically get access to the GitLab with these sample notebooks. You automatically get added to the Slack work group. So, you get access to this frequently asked questions document. So
yes.
all of that happens automatically.
Yes. We also have office hours every other Wednesday from 3 to 4 p.m. And then there's Atlas office hours every other Monday on the other weeks. So there's something every week that's related to OMOP usage. And then, yeah, we have a Slack workspace where you can ask more general questions of other users. And we have this frequently asked questions document, which I think doesn't get enough attention. There's a lot of information in here. There are
Yeah,
so
we have to
many
think about maybe
questions.
making it like, I don't know, more readable or something.
Yeah, but if you're looking for something and you're having trouble with something and you think someone else might have occasionally like come across the same thing, this has a lot of information, sort of institutional knowledge in it. So that's another great resource for you all. So I think that is it for today. Feel free to stick around if you have any questions that you want to just ask, about your specific access or needs or something like that. I'll stick around until 3, but other than that, that's it for the workshop. Thanks for joining, everyone.
Thanks a lot,
Thank you.
everybody.
Thank you.
The preceding program is copyrighted by the Board of Trustees of the Leland Stanford Junior University. Please visit us at med.stanford.edu.